Welcome to today's tutorial. So in this tutorial we're going to be finding the second derivative of implicit functions. Okay, so the first question is x squared. First question is x squared plus y squared is equal to 4. So even before we start solving, if you have not yet subscribed to the channel, make sure that you do so that you don't miss out the videos that I'm going to be posting. And if you have any questions, feel free to contact me on any of these lines on the screen. Okay, so this is what we're going to do. So x squared plus y squared, x squared plus y squared is equal to 4. That's the equation. So we're going to be finding the second derivative, which is the 2y dx2. And if you want to join the group where I post these videos on WhatsApp and Telegram, you can simply just contact me on WhatsApp on any of these same lines on the screen, and then I'll add you to the group. Alright, so the first thing that we're going to do here is first we're going to find the first derivative. So differentiating x squared will give us 2x, then differentiating y squared will give us 2 times 1 this side. We're going to get 2, and then the one that I'm talking about is the coefficient of y. 2 times the coefficient of y, which is 1, we're getting 2. Then we're going to write y, then we say 2 minus 1. So 2 minus 1 this side will give us 1. Then because we're differentiating y with respect to x, we always have to add dy dx, since this is implicit differentiation. Then on this other part we're going to have 4. Yeah, on this other part we're going to have 4, and then when differentiated it's going to give us 0. So we're going to make dy dx the subject by taking this 2x to the other side of the equal sign, meaning this side will remain with 2y, then dy dx is equal to negative 2x. Then if we divide everything by 2y, we're going to get dy dx as 2x over 2y. Of course this is negative. So when we simplify this, dy dx will therefore be equal to negative x over y. So if I want to find the second derivative, I can differentiate this expression here. So differentiating this expression, this part will give me the 2y dx2, but when differentiating this other part, I'm going to use quotient rule. If I don't want to use this expression, I can still use this same expression here. So for me, I find it easier to use this or this expression. So let me use this one. So I'm going to have, this one can be simplified as when I divide everything by 2 on both sides, I'm going to have y dy dx is equal to, then this side I'm just going to remain with x. I've just divided the whole expression, this expression here, by 2. So when you look at this expression here, we're having two functions multiplying themselves, meaning we're going to use the product rule to differentiate it. Then on this other part, we're just going to use the power rule. So the product rule here, using the product rule on this left side, we're going to equate, we're going to say let our u be equal to y and our v be equal to dy dx, so that if you find u prime, we're going to find, if you differentiate y with respect to x, the answer that you get to simply just be dy dx. And then when you differentiate dy dx to find v prime, you're going to find, your answer will be the 2y dx2. When you differentiate dy dx, you always get the second derivative. So when you differentiate this part, we're going to use the product rule. The product rule states that f prime of x is given by, if you have a function which is f of x, that is in the format u times v, so dy dx or f prime of x is given by u v prime plus v plus u v prime plus v u prime. So for the product rule, you can start with either u v prime, or if you want, you can start with v u prime. It's still the same because addition is commutative, So you can start with any of these terms, but for quotient you always have to start with v u prime. Okay, so we replace these expressions in this formula. So we're going to have our u is equal to y, then v prime is d2y dx2, d2y dx2. Then we have a plus in between there. We have v. Which one is our v? Our v is dy dx. Dy dx is our v, and then our u prime is also dy dx. So our u prime is also dy dx. So we also write it there, dy dx. So this dot which I've put here means multiplication. Okay, so this can also be written as y d2y dx2 plus dy dx times dy dx will give us dy dx squared. And please note that this is not equal to this part. They are two different functions. Okay, I mean there are two different derivatives. So we can replace this expression on this part. Yeah. So we have y. Let me just demarcate. Y d2y dx2, then plus dy dx there squared. That is this part, which is the derivative of this part. We say this is equal to the derivative of negative x will just give us -1. So here the question is asking us to find the second derivative. So meaning we make the second derivative of the formula as the subject of the formula. Or even before we do that, we can just replace our dy dx with what we found here. So dy dx is just equal to -x over y. So I'm going to replace it there. So I'm going to have y, then d2y dx2, then plus I'll have -x over y there squared is equal to -1. So what I'm just going to do here is to take this expression to the other side of the equal sign. Yeah, so I'm going to have y d2y dx2 is equal to this will become x over y, x squared over y squared, then we say -1. So I've taken this expression to the other side of the equal sign, and I've also opened the brackets so that this -x squared becomes x squared, then y squared also becomes y squared there. So I'm going to divide everything by y so that I remain with the 2y dx2 on this side, which is the second derivative. So the 2y dx2 is equal to, when I divide everything by y, I'm going to get x squared over y to the power 3 minus 1 over y. So this is the second derivative of this function here. So it's as simple as that. It's not as difficult as you thought it is. Okay, so let's quickly move on to the next one. I'll solve 3 questions and then I'll leave the other questions for you to solve. So let me also solve this one. I'll just be picking random questions. Okay. So let me solve this one as well. So f is y to the power 3 is equal to 4x. So differentiating this first part here will give us 3y squared dy dx is equal to, when you differentiate this part, the answer that you are going to get will be okay. So when you differentiate this part, the answer that you are going to get will be 4. Yeah, so when you get 4 as the answer, you are going to also make dy dx as the subject. So making dy dx as the subject will give us 4 over 3y squared. Then after doing this, we can now find the second derivative. So I like using this expression to find the second derivative. So if I use that, I'll first divide everything by I'm going to first divide everything by 3. So if I do that, I'm going to have so if I do that, I'm going to have y squared this side, dy dx is equal to 4 over 3. So if we have such, we can now so if we have such an expression, we can now find the derivative on the left and also on the right. So when you differentiate this part, what we're just going to get is, so when you differentiate this part, what we're going to get is simply just so we're just going to get we're going to use the product rule as well. So differentiating y squared, I'm going to do a shortcut here because I showed you how to use product rule in the previous question. So when you differentiate this one, which is y squared, I'm going to get 2y dy dx, then 2y dy dx times dy dx, then we say plus, when you differentiate dy dx, you get the 2y dx2, then this is multiplying itself with y squared, then we're saying this is equal to 0. Okay, so from there, the other thing we have to do is we make the 2y dx2 the subject of the formula. So what we're going to do first is to replace dy dx with its expression here. Or if you want, you can first make the 2y dx2 the subject and then you replace dy dx at the end. Okay, so we have this expression. So we'll take these, or let me first simplify it. We have 2y dy dx times dy dx. We're going to get dy dx squared, and then we have plus y squared the 2y dx 2. This is what we have, and then we say this is equal to 0. So just take this to the other side of the equal sign, and when we do that, so when we do that, we're going to have, when we take this part to the other side of the equal sign, we're going to have y squared the 2y dx2 is equal to negative 2y open brackets dy dx, of course, squared. Then we divide everything by y squared, so we're going to get or before we do the division, we can replace this dy dx with what we have there. So we have y squared the 2y dx2 is equal to have negative 2y, then open brackets, while there's dy dx, I'm just going to replace with 4 over 3 y squared. So we have 4 over 3y squared, and then we've squared this. Then we also now divide everything by y squared so that we remain with the 2y dx2. So this will now be equal to, so this one outside will give me negative 2. When I divide by y squared, I'm going to remain with, of course, 1y will cancel with 1y there, so meaning I'm just going to remain with y down. Then this other part will simply just be 4 squared will give me 16, everything divided by 2 squared will give me 9, and then y squared to the power 2 give me y to the power 4. So the second derivative will therefore be equal to, 2 times 16. This will give us negative 2 times 16 will give us negative 32, everything divided by 9y to the power 5. So this is the second derivative. So these things are simple. It's not something that you need to even spend a lot of time to solve. Okay, so let's quickly move on to the next question. Okay, so the next question I'm going to solve, of course, this one and this one, they are not very much different. Yeah, so I think let me solve this last one, and then you solve the other questions. If you are not sure of your solutions, you can send them over to my WhatsApp line, and then I'll confirm if it's correct or wrong. So let's quickly look at this expression here. So we have xy minus 1 is equal to 2x plus y squared. Okay, so differentiating this first part here, we're going to have we're going to use the product rule, of course. So differentiating this part using the product rule will be, first we differentiate x, which will give us 1, and then times y, say plus, we differentiate y, which will give us dy dx, so times x. I'm using the shortcut for product rule, which I'm sure you can use when you just follow the right steps, which I showed you in the first question. Then we're multiplying this by x, then we say minus the derivative of 1, it simply just give us a 0. So this will be equal to the derivative of 2x here will give us 2, and then the derivative of 2y will simply just give us, the derivative of 2y will simply just give us, rather the derivative of y squared simply just give us 2y dy dx. So we're going to pair the terms which have dy dx so that we make dy dx the subject of the formula. So pairing the terms which have dy dx, we have this term which is x dy dx, then time we take this to the other side of the equal sign, so meaning we have negative 2y dy dx, and then we also have this to this side. We say this is equal to 2, then y will go to the other side of the equal sign, which is just going to be minus y. So we factorize dy dx, and say open brackets, we have x minus 2y of course, is equal to 2 minus y. Then if we make dy dx the subject, we are going to say, so if we make dy dx the subject, we're going to have this to be equal to 2 minus y over, then we have x minus 2y. So to find the second derivative, I'm going to use this expression, because if I use this one I might complicate things. In short, the procedure might be long, so let me just use this one. Though in differentiating this I'm going to use quotient rule because I'm dividing two functions. So actually I can even use this one. Or even just this same one here. So if I use this one, it means that I have to use product rule to differentiate this part. So using product rule to differentiate this part, this first part will be my u, the second part will be my v. So we differentiate that using product rule. So we're going to have, and then this other side we differentiate it just the normal way. So let's differentiate the first part, which is this side. So to differentiate this, we differentiate first dy dx. So when we differentiate dy dx, we're going to get the 2y dx2, then open brackets x minus 2y, then we say plus, when you differentiate what is inside there, you're going to get 1 minus dy dx, 2 dy dx. You're going to have 1 minus 2 dy dx, because when you differentiate x you're getting 1, when you differentiate 2y you're getting 2 dy dx. Then we're multiplying this by dy dx, and then we say this is equal to, differentiating 2 there will give us 0, then differentiating negative y will give us negative dy dx. So at this point now we can just make the 2y dx to the subject of the formula. And how do we do that? First we can open the brackets here so that we simplify the expression. So we're going to have something like this. We're going to have the 2y dx2 is equal to or let me first take everything to the other side of the equal sign, then divide by this. So I'm going to have something like negative dy dx, which is this expression, then minus this entire expression, which is 1 minus 2y dy dx times dy dx, then everything divided by this expression here, so that I just remain with the 2y dx to this side, x minus 2y. So if there's a way you can simplify it, you can do it by replacing while there's dy dx, you just put this function there, then the final answer that you're going to get is the solution for this. So let's try to do that. If the space finishes, then you're going to finish it on your own. So we have the 2y dx2 is equal to, so we can factorize if you want. You can say this is just the same as dy dx, then open brackets, then we have negative 1 minus dy dx, rather negative 1 minus negative 1 minus 1. I'm trying to factorize dy dx, so I'm going to remain with negative 1, then there I have negative 1, so this will just remain as negative 1, and then we say minus, so negative times negative will become a plus, then we have 2y dy dx. So I've just factorized that. Yes, so I've just factorized that. Okay, so from there we can simplify it further. We can say the 2y dx2 is equal to, while this dy dx, we can put 2 minus y over x minus 2y. Then in brackets there, negative 1 and negative 1 will add to get negative 2. Then you have 2y, we say plus 2y, then while there's dy dx, again we replace with that, so we change the types of brackets here, so we can have that part replaced by 2 minus y over x minus 2y. So if you can simplify it further than this, you can go ahead. What is important is us finding the second derivative. Alright, so thank you very much for watching today's tutorial. In case you have not yet subscribed to the channel, make sure that you do so by clicking on the subscription button. And if you have any questions or contributions, or you have maybe you've seen a mistake where I've made a mistake as I was solving, you are free to contact me on any of these lines on the screen, so that we can talk. And if in case you want to join the WhatsApp group where I post these videos, feel free to contact me. I'll add you to the group. My name is Harmtedy. Shalom, shalom.